I was sent an email this morning. Somebody wanted to know about relays. Wants to do some extra lights on his car, and the instruction asks for a relay. I'm not sure if we've done a subject on relays before, but today's the day. So what is a relay? There. See ya. No, what does a relay do? It's an electrical switch. I was going to say electronic switch, but you can get electronic switches, but it's an electrical switch and it's a mechanical switch. So what it does is it uses a low amperage circuit to turn on a high amperage circuit. That's about it. That's the bones of it. We'll look down on the bench here, and I've sort of done a diagram how it actually works. The 85 and 86 that's mentioned here goes through a coil. So it doesn't matter which way around it goes, positive or negative, it doesn't really matter. So if you put a positive feed into here, low amperage, maybe 1 amp, it will energize this coil, and through a series of levers and magnets and things like this, it will turn this switch from open to closed. Now this can be a high amperage, like for example a starter. This is a typical relay, but we call it a solenoid because it does different things. But it's exactly the same principle. You put a small amperage in here, small power, 12 volt, and because it's grounded through the body, it goes through a coil and energizes a contact in here, which contacts this wire to this wire and makes a starter go. So we can use a maybe 1 or 2 amp circuit to do a big job. Because think about it, if you didn't have relays to turn the starter on, you would need a battery cable coming all the way to the ignition switch, turn a massive ignition switch, and then from that big massive ignition switch go straight to your starter. The current would just be absolutely enormous, and all the wiring and stuff like this. So what they do is they just make a run from the starter here to the battery, and that's it. So you need just a short run, saves money, and it's more convenient to do. But relays come in all different sizes, look. They're all different, you know. Now you could probably notice here, this is a 5-pin relay. We'll do a demonstration in a minute what they do, but a 5-pin relay would be 87A. These are the contacts. Now if you look on the bottom of a relay, it will say clearly what the contacts are, so you can't get the wires on. And due to international wiring regulations, they're always the same. 85, 86 through your coil, 30, 87, 87A, depends on if it's normally open or normally closed. If it was like these 5-pin relays, you would have a continuity through 87A all the time. It's like a switching relay type of thing. So it switches from one state to another state. So when you energize this coil, this would flip-flop over to this side and break that current, if you see what I mean. An easy way of demonstrating it is with this little device here I make for testing relays. But let's have a look in a relay. There's one I broke earlier. You can see the coil here, and you can see, where is it now? There they are. There's the points there. So when this moves, when this coil is energized, it draws on this plate here to close those points. You see? That's all it ever does. All that power goes through these little points here. So when you put your headlamps on, for example, you want to put your fog lamps on, or spot lamps, or whatever it is, you need a suitable amperage relay. Now this is a 30 amp relay. You can get them bigger. It doesn't really matter. The bigger the better, really, if you're turning lights on. So when you energize the coil through wires 85 to 86, the little plate here will come on, because this is just a magnet, pulls the plate on and makes the contacts between 87 and 30. Easy. So I bet you're dying to see my switch. I'm sure I've showed you this before, but anyway, never mind. We'll have a look at it again. We've got two relays that's quite common in Land Rovers here. The yellow one is a 4-pin relay, like on this diagram. The green ones here are a 5-pin relay. Now, for some strange reason, on some Land Rovers they have a metal bodied, these Lucas ones, but they do exactly the same. And we can demonstrate that by putting it into our tester and find out, like I said earlier, when you've got no current, these aren't working, there's current going from 87A to 30, right? When you press the button, it switches over to this side. See, it's like a switching relay. Now this one here, this little light that comes on here, tells you that this relay is working. Alright? And you can hear them. Alright, so this is my little relay tester I knocked up. But that's all they do. So all I'm doing here is applying current to go across here and here, which then applies current between here and here. Now it doesn't really matter with this one because it's just for testing purposes, but you could use it for different high currents. And that's about it. You can also use them, if you want, for switching between voltages. For example, you could use a 12 volt going through here to switch 24 volts going through here. It doesn't matter. They're an incredibly useful little tool to have around. But you'll find a lot of fuse boxes and things like this are full of different relays. But they all control higher amperages. Like heaters, for example, heater motors. It's not really advisable to run a heater directly through, you know, like a 2 amp supply. It would draw too much current. Land Rovers Defenders do. They just put it straight to the main harness. And one of the main problems with Land Rovers is the headlamps, because a lot of people put different bulbs in and bigger bulbs and this, that and the other. But on a Land Rover there's no, well, I'll have to be careful on this because the early ones didn't have relays for the headlamp circuit. So the wiring used to go from the fuse box to the wiring stalk, you know, for your high and low beam or whatever. So as soon as you switch your lights on, power then went from your light switch to your high and low switch. And that basically was a physical relay. You had to turn it on and off yourself. So it was an idea to put a relay in that circuit to use the low amperage to switch a high amperage on. That's getting a bit technical. We'll cover that in another day. But basically that's all relays do. And if you follow the wiring down below here, 85 and 86 is your low current. So say for example this chap wants to wire in fog lamps on the high beam to come on. You'd take a tap off your high beam lights circuit and then to ground, which would energize this coil, and then your headlamp, your main lights would have a positive feed coming through feed 87 and feed 30 would go to your lights. It doesn't really matter which way it goes around, it's the same, but you know, but if you follow those codes, 85, 86 is your low current, 87, but sometimes, like I say, you've got 87A, like in this instance, which is on all the time. Now that seems about as clear as mud, but basically the most of the relays you'll find, not that one, not that one, they're sort of like this. They're just a 4-pin relay. I've made a bit of a mistake that, but usually on here is a diagram trying to show you what it is, and you can see there quite clearly. There's your coil in the middle. It's a little box with a line through it. That's your coil, and you can see just above it, that is the contacts inside the relay. You can't go wrong really, but it's always advisable to put a fuse in them. All right, put a fuse in your low current circuit just in case you actually get a fault and it blows. You know, if wires chaff or anything like that, always put fuses in. Now, how do you determine the amperage? Well, of a fuse, well, we could go down a real big rabbit hole here trying to work out fuse sizes. But you can, usually if you're putting lamps in, it will tell you what size fuse you need to protect that circuit. All right. I don't really want to go down into that, because you'll be following me and putting different fuses in and blowing fuses left, right and centre if you're trying to turn something on that's really how do we say, high power, and you get it the wrong way around. So we'll leave that for another day. But that is relays.